Consider this configuration of lights coming from a 3x3 version of lights out. Recall how we can play this game mathematically by first representing the configuration of lights with a 9 tuple of zeros and ones. So in this case, the 9 tuple represented this configuration will look like this. So from the first row, I have off, off, and on. That gives me 0, 0, and 1. The second row gives me 1, 0, 1. And the third row gives me 0, 1, 0. The action of pressing each square is also represented by a 9 tuple. In the table here, you see 9 tuples, each of which correspond to what happens after pressing the corresponding square. If I look at the first 9 tuple, it corresponds to the squares that are affected when square 1 is pressed. Square 1 is this one, and the squares that are toggled are square 1, 2, and 4, which are these 3. So in order to find out what happens after pressing square 1, you simply add this 9 tuple to the 9 tuple that correspond to the configuration of lights. Now let me call these tuples T1, T2 up to T9. A solution to the puzzle is simply a selection from these tuples T1 up to T9 such that if you add them to the 9 tuple representing the configuration of lights, you get a tuple of all zeros. Now if I indicate my choice of selecting tuple I by xi, then basically this is the same as saying I want to find a way to assign values to x1 up to x9 such that this equation holds. Each of x1 up to x9 is 0 or 1. 1 means that I'm choosing the tuple and 0 means that I'm not. And you can see why, because if x1 is 1, this is simply t1. If x1 is 0, then this will just give me the tuple of all zeros. Now, notice that if I add the tuple that correspond to the configuration of lights to both sides, I get the following. We are going to evaluate this and see what happens. So I have x1 times t1. That means if I look at just the first entry, I will have x1 plus, and there's a 1 here, so I'm going to get x2, and I'm not going to get x3, but I'm going to get x4, and none of x5 to x9. So if I just look at the first component, it will be x1 plus x2 plus x4, and it has to equal 0 because the first component in the right hand side is 0. And I can do this for every other component, and what I will end up with is the following system of equations. So here are the 9 equations that come from the 9 components of the tuples. So the left hand side come from evaluating this, and the right hand side will simply come from this tuple here. Now this is a large system, and we want to solve this system in the sense that we want to find values for x1 up to x9, 0 or 1, such that all equations are satisfied. And this is just for 3x3 board. When you play with the original version of Lights Out, you have a 5x5 board, so you end up with 25 equations. So we need to find a way to systematically solve this kind of system, and that's something that we'll study. But in the meantime, can you find a solution to this system? Remember that we are using the rule 1 plus 1 equals 0. So give that a try, and good luck.